Today is the 24th of June 2021. You own $200,000 of a zero coupon bond maturing on the 14th of July 2029. The semi-annual interest rate is 3.75%. What is the present value of your bond position? Find the Macaulay duration, and then use the Macaulay duration to estimate the profit or loss if the semi-annual interest rate changes to 3.3%. So, we're going to find the present value, we're going to find the Macaulay, we'll find the modified and Macaulay durations, and we'll find the change in present value. Okay, so I've got an Excel spreadsheet set up to do this work because the calculations are a little easier there, or at least easier for me. So I'm going to put our data into the spreadsheet. So June 24th, 2021. The principal is $200,000. The maturity is July 14th, 2029. The interest rate is 3.75%, and eventually that's going to change to 3.3%. Okay. Because I'm going to use this repeatedly, I'm going to calculate the years to maturity. There are 2,942 days between these two dates. I'm just going to calculate that in Excel. Remember, we can take the difference of dates in Excel, and we'll get the number of days. So we take the number of days divided by 365, and this zero coupon bond matures in 8.06 years. The present value of this bond is $200,000 times the interest rate is semi-annual, so 1 plus the interest rate divided by 2 to the power negative 2 times time. So that's our standard formula for semi-annual compounding. The derivative, and I know the derivative off the top of my head, but you can take the derivative using the chain rule, and you're going to get negative t times the principal times 1 plus y over 2 to the power negative 2t minus 1. So negative t times the principal times 1 plus the interest rate divided by 2 to the power negative 2 times t minus 1. So again, that's a power rule and then a chain rule. Oops. So let's make that a little bit wider. So the derivative is a big number. The modified duration is the opposite of the relative rate of change of present value, which is the derivative of present value divided by the present value. So it's the opposite of the derivative divided by the present value, 7.91. The Macaulay duration is this number times 1 plus the yield over 2. Modified duration times 1 plus the interest rate yield divided by 2, 8.06. And notice that's the same as the years to maturity. Macaulay duration is the average time when the present value is paid to you. Since we only have one cash flow, that's going to be when the cash flow is paid, or 8.06 years. All right, so we have two formulas, the same formula really, for estimating profit and loss. DPV is equal to negative present value times modified duration times the change in yield. So that's negative present value times modified duration times the change in yield. 3.3 minus 3.75, $5,278. Interest rates went down, bond prices go up, we make money. If we're using Macaulay duration, it's negative present value times Macaulay duration divided by 1 plus the interest rate divided by 2 times the change, interest rate, 1 plus the original interest rate divided by 2 times the change in interest rates. New interest rate minus the old interest rate, 5,278. Not surprisingly, we have the same answer here because these formulas are essentially the same. Change in present value is the derivative of present value times the change in yield. Modified duration, Macaulay duration are different ways of looking at the derivative. So let's just check our work here. So This present value should be 148,243.45. The Macaulay duration is 8.06. And the estimated change in profit and loss, or the present value, 5278. Check. Got everything right. Looks good.